Hello, class 12th physics, optics, important question for boards as well as competitive exams. Prism ABC of angle 30 degree has its face AC silvered. A ray of light incident at an angle 45 degree at the face AB retraces its path. It retraces its path. First, this angle is 30 degree. So ray retraces its path. It means it is incident at an angle 90 degree. There is some challenges for me to draw this diagram. Let us suppose this angle is 90 degree. It's not supposed to be that angle, actually not drawn to uh, proper scaling. So let us suppose this is at 90 degree. So it incident on it so that it will retrace its path. There's no way by which it could retrace its path. There is only way if it incident on this face at 90 degree. So we have prism formula, but we will not use that because it works on if there is a minimum angle of deviation is given. So what else we can do? So remember, for this refraction due to prism, there is an angle of incidence I, then there is angle of refraction R1, and on this face there is angle of incidence, but we write it R2. And then so one more important outcome for that derivation is R1 plus R2 is equal to A, and here we will use the same. So here it is, R1 we don't know, R2 it is not 90, actually 90 degree it is making with the surface, but angle is taken with normal. So with normal it is making 0, and A is given 30 degree. So R1 is, this angle is 30 degree, and what is angle of incidence? We have that 45 degree. I is 45 degree, and now for this interface you have angle of incidence, angle of refraction. You can find refractive index of your own. Now this is a tricky question. A ray of light incident normally on an isosceles right angle triangle isosceles. So this is 45 degree, this is 45 degree, and least value of refractive index. Okay, so first of all, this angle of incidence is also 45 degree just by geometry. Try it of your own. How is it so? But that is 45 degree angle of incidence for this surface inside this, and it is getting total internally reflected. It means for the material of this prism, critical angle is critical angle because here angle of incidence is 45 and rays going total internally reflected. It means I is greater than IC. It means critical angle is less than 45 degree. Now how are we going to relate it with refractive index? So we know that refractive index, I use eta, you can write mu, no problem, is equal to 1 upon sine I subscript c, and we don't know what is the value of ICC. This is value of I, not IC. So how are we going to do that? Well, IC is somewhat less than 45. It can be 44.9 or whatever. What I'm doing, I am just tossing the coin. I mean, making a guess. I'm taking sine of this. Sine IC, I mean, whatever be the critical angle here, its sine must less than sine 45. Means sine IC must be less than 1 by root 2. It means 1 by eta from here must be less than 1 by root 2. It means eta must be greater than root 2. Now all of these values are greater than root 2. So all of them are the answers, but they have asked for least value of refractive index. So just greater than this value you can find of your own. Here it is. A given ray of light suffers minimum deviation in an equilateral prism P. Additional prism Q and R of identical shape and identical material are now added as shown. The ray will suffer. Now what will happen? See, we know this formula as a prism formula for minimum deviation, of course. Now we can say this minimum deviation depends upon A and eta, nothing else than that. So if we have made entire arrangement like this, so if ray would incident somewhere here, it has nothing to do with what is on upper side, because this ray will not going to get deviated because something is on the top of it. So let us suppose another thing is kept over it. another similar prism, so that it will look like a bigger prism. So let us suppose ray was going like this, and I don't know, but it is not going up there, and it is coming out from somewhere here. Now remember, because angle of vertex or angle of prism is same as this one, material is same, so now decide, will there uh, any other deviation, or will it be the same? I'm not telling you the correct answer. Here it is. It is just a fact-based question. A ray of light incident on equilateral prism, this one, for minimum deviation again, which of the following is true? Remember, for minimum deviation, there are several conditions. I is equal to E, angle of incidence becomes angle of emergence. So R1 is equal to R2, as I told you, those R1, R2. So, and ah, delta equal to delta M, that is a joke. And finally, this refracted ray which travels through the prism is parallel to base. Remember that condition. Okay, a thin prism mu 3 by 2 is dipped in water. Okay, then minimum deviation, angle of minimum deviation will be that much times than it was in air. So it is a direct question, and again, it is about minimum deviation, but we are not going to use this. For thin prism, we have delta m equal to eta minus 1 a. And there are two conditions. In one, there was thin prism uh, in air. So delta m for air is equal to, at that time we will take refractive index of this 3 by 2 minus 1 multiplied by a. And in second case, minimum in water. And remember, this time you need not to put this. Actually, earlier it was, this is the refractive index of glass, and earlier there was air. So actually this refractive index is the refractive index of glass with respect to air. Now there is water. So you need to find refractive index of glass with respect to water, which is eta g by eta a, which is 3 by 2 by 4 by 3, and which is 9 by 8. And now you can solve it.